All right, in lesson 11, we are going to look at the relationship between fractions, percents, and decimals. This lesson is really important that we see that all the fractions, percents, and decimals, all those types of numbers are related. It's kind of like having three different languages. If I wanted to say hello in English, it'd be hello. If I wanted to say hello in Spanish, it would be hola. And if I wanted to say hello in Japanese, it might be konnichiwa. But they all still mean the same exact thing. So that's how it is with fractions, decimals, and percents. The first word we're responsible for knowing is what a percent is. So we haven't done this yet, but a percent is just a special type part-to-whole ratio comparing a part to a whole. And what you're comparing always in percent is something out of 100. So when I write a percent number right here, so I'm just going to write 72%. We have to know what that means. It means you're comparing the 72 to 100. I tell kids, if you really look at this percent sign carefully, you can kind of see the number 100. There's a 1 with 2 zeros. So when I see percent, a percent sign, I'll know, okay, at 72 hundredths. A lot of kids struggle with that. You constantly need to be reminded of what the percent sign is. And so it means out of 100. Okay, we're going to do a review question. This is actually from the lessons 1 through 10. Let's just start. It says the length of a 1923 model train is 2 inches long. If the scale of the model to the actual train car in the museum is 1 inch represents 20 feet, what's the actual length of the car? Okay, hopefully you remember from the scale questions, anytime they give you scale, that is your ratio statement. That's what we're comparing. So immediately I'm going to write the scale in my if box. So I'm going to write if 1 inch is 20 feet. So that's the scale that was given to me. I now know my labels have to match it across. This is going to be inches, this is going to be feet. We need the actual car length of the car, and we know the model is 2 inches. Well, this one's pretty easy because they give us 2 inches. That must go up in the inches spot. And the question is, how much is a real car? There's many ways to solve that. You can always resort to multiplying across and dividing. Obviously, 20 times 2 divided by 1, and the answer is 40. Or you could have just went, the top is getting 2 times bigger, the bottom needs to get 2 times bigger. So the actual length is 40 feet. So that's just a review question. That should be pretty easy for you. Okay, now we're going to actually start looking at fractions, percents, and decimals. At the bottom it says, this grid has 100 squares. If we shade in 50 of the 100 squares in the grid, what's the ratio that tells how many squares are shaded? So if we write this as a ratio, and we say ratio compares two numbers, they want to say the ratio that is shaded. So the top number, there's 50 shaded out of 100, because isn't there 100 total squares? So there we have a ratio. Definitely looks like a fraction, doesn't it? And so our ratios are going to be our fractions. If we were told to reduce it, it would reduce, I could divide the top and bottom by 50. So 50 goes into 50 once and into 100 twice. If we're not told to reduce, it's going to be fine, unless it does say put it in simplest form. So otherwise 50 out of 100 for now is okay. The next question says, what would the ratio be if you shaded in 30 squares in a 100 ratio grid, or sorry, 100 square grid? Explain how you would write that ratio. How would you express the ratio as a percent and a decimal? So we're just going to write it as a ratio first. We need to say the ratio that's shaded. So the top number would be 30, because 30 shaded out of 100 total. So that's my ratio. I'm just comparing the shaded to the total. So if I even wanted to label it, I could. So there's my ratio. The question is, how would I make that a percent? Well, if you remember, the definition of a percent is any number compared to 100. We're comparing this 30 to 100. So it's pretty easy to write as a percent. It's going to be 30%. Remembering that this percent, this sign right here, means 30 out of 100. So that's how you write that as a percent. And then a decimal, well, we should just know that we're talking about hundredths. Remember how we looked at that? There's 2 zeros on the bottom, so past the decimal, we got to have 2 spots. So here's my decimal. So I'm going to have 30 over 100, or sorry, 30 out of 100. You could also just drop that 0 and say it's 0.3. Either one of those would be okay. Okay, the next example says write 25% as a fraction in a decimal. So now they're taking away the pictures. When I say write 25% as a fraction, well, I know exactly what that number means. So 25% means 25 out of 100. There's my fraction. Now we are pretty picky in our ruling on our fractions. We always want to reduce fractions if possible. So I can divide the top and bottom by 25. So 25 goes into 25 one time, 25 goes into 100 4 times. So I would like your fractions to be reduced. A decimal is pretty easy. So I'm at a percent, and I want to know the decimal. Well, I know it means 25 hundredths, so the fact that there's 2 zeros means I'm going to have my decimal, I have 2 spots past it, and then the number 25 has to go there, so 0.25. There is a little chart you can use if you need it, and it looks like this, D2P. If you're given a percent, which you are right there, you want to go to a decimal. So you use your chart like you do your metric chart. So you'd write that at the top of the paper. This means decimal 2%. So I'm given the percent. I want to go to a decimal. I'm going to count how many spots. I moved my finger. I move my finger 2 spots to the left. So in the number 25, if that was 25%, and I'm at a percent, I want to go to a decimal, I'm going to slide the decimal 2 spots over, and that's going to be my answer. 2b says give some examples of equivalent fractions for 1 to 5, or 1/5. So basically all we have to do is come up with fractions that are equal to that, so we should be pretty good at that. Remember, whatever you do to the top, you have to do the bottom. So if you want to go, I want to go 2 times bigger on top, 1 times 2 is 2, and then 2 times bigger on the bottom, 5 times 2 is 10. Got one? If I had said you got to give me another one, so you would do, let's multiply by 3. So 3 times 1 is 3, 3 times 5 is 15. On this question it says, if the whole grid is 50 squares and we have 30 squares of the grid shaded, can we say that 30 squares, which is the part, out of 50 squares whole, is 30%? So if you look, they basically changed it, and if you look at your ratio, so your ratio is 30 shaded compared to 50 total, because they're saying this is now the new square. That would be the ratio. Obviously the fraction would be 3/5 if you reduced it, but could we say that is the same as 30%? And the answer to that would be absolutely not. Because if you remember, the definition of percent is comparing a number to 100. So in order for it to be 30%, you would have to have 30 out of 100. And you don't. You only have 30 out of 50. So the answer would be no. On this next question, it does say find some equivalent fractions for 30/50ths and find one that has a denominator of 100. So if we went, well, what is equal to 30/50ths? Probably the most obvious equivalent fraction would be to reduce it. You can divide the top and bottom by 10. So 10 goes into 33 times and 10 goes into 55 times. So there's one equivalent fractions. We could give a lot more. However, they do say they want one with a denominator of 100. So if I just write 30 out of 50 right there, basically, they're telling us change the bottom number to 100. You can see you're getting twice as big on the bottom. We would need to get twice as big on top, which means this would be a 60. And now that we actually have that out of 100, we should know that 30 out of 50 is the same as 60% because it's 60 out of 100. 3C says change these all into percents. Well, you can look. All of them, none of them have a bottom number of 100, do they? And since percent means out of 100, if I change the bottom number to 100, figured out what the top number is, that would be the percent. So if you look at this first one, you're getting 20 times bigger on the bottom, so we need to get 20 times bigger on top. So that's going to be 40 out of 100, which means it's going to be 40%. You can see that percent sign again, kind of resembling the number 100. So the next one is 40 out of 20. If I can change that bottom number to 100, I can find the percent. And getting 5 times bigger on the bottom, I need to get 5 times bigger on top. That's going to be 20 over 100, which is equivalent to 20%. So the percent sign just takes place of the out of 100 part. This next one, Changing that bottom number to 100 again. I'm getting 4 times bigger on the bottom. I'm going to have to get 4 times bigger on the top, which means it's going to be 40 out of 100, which is the same as 40%. This one is going to be a little trickier. I can still make the bottom number 100, but here's the problem. I have no idea how many 40s. 40 times what gives me 100. So when it's not super obvious, remember the other way we can solve all problems is we can multiply these numbers diagonally. So I'm going to take 11 times 100, which is 1100, and then divide by the other number. So I'm going to divide by 40, and you can do this using a calculator. The answer is 27.5 out of 100, which means it's going to be 27.5%. In this question, it says in baseball, the batting average is calculated as the ratio of the number of times you get a hit to the total number of times at bat. This table shows the batting average of Aiden, Bob, and Dan during a baseball game, expressed as a fraction, a percent, or a decimal. Some information is given and some information is missing for each player. We'll complete the information for Aiden and Bob, and you complete the table for Dan for homework. Actually, we're going to do all of it together. So basically, let's just look at Aiden. And I'm looking at Aiden, and it's 3 out of 10. I need to change that number to a percent, which hopefully you remember just means make the bottom number 100. So you can see this is getting 10 times bigger. This has to get 10 times bigger. Oh, that's the same as 30 out of 100. Sorry about my messy writing. And so I know 30 out of 100 would be 30%. The decimal, 3, if I look at my fraction, 3/10, if you have, first of all, in your head, you should know what that is, and is a decimal, 3/10. What does 3/10 look like? But if you can't figure it out, you can always take your fraction and take the top divided by the bottom, so 3 divided by 10, and you're going to get 0.3. Okay. When we have the decimal given, so I'm going to remember that little chart we talked about, D2P. We're going to use that now. Okay, if they give us a decimal, which they did, we want to go to a percent. Do you see how I'm moving my fingers 2 spots to the right? That means this decimal here has to go 2 spots to the right. So I'm going to be moving it. It's going to end up being 25%. Common sense should tell you that's the same answer, because isn't that number 25 hundredths? And doesn't 25% mean 25 hundredths? So even if you don't use this chart, you should still be able to figure that out with your common sense. Going to a fraction. So I'm at a percent and I want to go to a fraction. I should just write down what it means. 25% means 25 out of 100. And all I have to do is reduce it. I could divide the top and bottom by 25. It gives me 1/4. We do want those fractions in reduced form. All right, and we're going to finish with Dan. Dan is 40%. I want to go to a decimal. I'm going to use my chart up here. I'm at a percent. I want to go to a decimal. That means I'm going to move 2 spots to the left. The decimal and the number, if you don't see it, is at the end. Move it over 2 spots to the left, so it's going to be 0.4. If you put 0.40, that is also the same thing. So it doesn't matter if you drop that end zero off or not. And then as a fraction, well, I know 40% means 40 out of 100. And if I wanted to reduce that, I could drop the zeros off, because that's basically dividing by 10. So I have 4 over 10, and I could divide by 2. 2 goes into 4 twice. 2 goes into 10 5 times. Okay, this I know on the screen is really hard to see, so you're going to have to probably look at your paper to understand it better. But it says this circled graph depicts how Mary spends her time every day. It shows how many hours per day Mary spends on the following activities: sleeping, eating, going to school, completing homework, and hanging out with friends. There is a major problem on this circle graph in the fact that, like, this number right here says homework, and it says 4%. It should not say 4%. It should be 4, which is referring to the hours. Okay, and then this is sleeping. I know you can't see that, but this is the sleeping part right here. And that number is 8%, but it should just be the number 8, like 8 hours, not 8%. This bottom part is school, and that says 7%, but it should only say 7. This one is the hanging out. That one's going to say 3, and this one is the eating, and that one should be a 2. So I kind of filled those in for you a little bit to help you, but you can look at your paper and you'll be able to see those words. First question, what fraction of Mary's time is spent sleeping and doing homework? So if we look at sleeping is right here, that's 8. Homework is right here, that's 4. So 8 and 4 is 12 hours. So we have to think about how many hours are in a day, because that would be our total. When we do fraction, we have the part over the bottom's a total. So in a total day, there's 24 hours. That would be the bottom number. And if we add up the sleeping and homework, we get 12. So there's our fraction, 12 out of 24, but hopefully we know to reduce our fractions. That is going to reduce down to half, because you could divide the top and bottom by 12. 5b, what fraction of Mary's total time is spent not going to school? So total time not going to school. So school right here is 7. So her total time is going to be a 24. Okay? And so her total time not going to school, well, you can see there's 7 hours going to school. Hold up. 8, 15, 18, 19, 20. Yeah. What I was just checking is to make sure that all these numbers add up to 24 hours, because there's 24 hours in a day, and it does. So that's good. So the total time is not going to school. So if 7 hours are going to school and there's 24 hours in a day, we could just subtract them. So basically it's going to be 17 out of 24. And 15C, when added together, what 2 activities did Mary spend 25% of her total time on? So this question we're going to fill in our little graphic organizer. So the first thing you're going to underline, anytime you have a percent number, you're going to immediately, that's your ratio. I see 25%. I know that means 25 out of 100. So that's going to go in our circle for our ratio. So what 2 activities she spent 25% on? This is going to be hard to write a label because we don't really know what we're going to label at top. But we do know the bottom on percent is always the total. So if I think about that, and this is going to be the total amount of hours in the day, we should know that that's going to be 24. All right, so 24 hours in a day, it's 25%. We're looking for how many hours that is. So you can multiply across. You're going to get, when you multiply across, you get 25 times 24 is 600. Then you're going to divide by 100, which is 6. So we have to figure out what 2 numbers on here equals 6. Because our answer would be 6, but the question is saying when added together, what 2 activities is 6? And you can see it's this one and this one, the 4 and the 2. So basically it's going to be homework and eating. Okay, on this question it says the target star in Minnesota is divided into 8 smaller sections, A through H. They want the floor map for the target store to be drawn on a grid of 100 squares divided into 8 smaller sections. We have to compare the squares in each section to the total number of squares. Write each comparison as a fraction and as a percent. Okay, we're not going to go ahead and do every single section because that would be a little repetitive. So we're going to pick the ones that are pretty easy to see right now. So if I went just here and started with D. So I'm going to count section D. So D is 1, 2, 3, 4, 5, 6, 7, 8. So if I want to look at my fraction, which is probably going to be the easiest right away, D is 8 shaded, or there's 8 squares out of, and remember how they said this whole grid is 100? So it'd be 8 out of 100. Now that I know how much that is, it should be very obvious that would be 8%, because 8% means out of 100. But remember how we said... oh, sorry, we should fill in this too, that there's 8 squares is the section size. We should reduce our 8 out of 100. You can divide by 2, you would get 4 out of 50. You could divide by 2 again, and then you would get 2 out of 25. So we always want our reduced fraction to go right next to the original fraction. Okay, let's go ahead and do F. So we're going to count F too. So F is 1, 2, 3, 4, 5, 6, 7, 8, 9. So F is 9 sections. The fraction obviously would be 9 out of 100. And then the percent is pretty obvious. It's going to be 9%. The nice thing about 9 out of 100, it is a reduced fraction. All right, let's go ahead and do B. So B is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So B is 15 squares. The fraction then would be 15 out of 100, which makes the percent super simple because the percent would be 15%. Then you're just going to divide the top and bottom by 5 to reduce that fraction. 5 goes into 15 3 times, and 5 goes into 120. I think that's good enough for that problem. You should have the hang of that by now. The next question says, for the 2013-14 Gopher football season, 27 of the 104 players on the team are seniors. What percent are not seniors? Okay, so we can see 27 out of 104 players are seniors. So if I underline my ratio statement, it's right there. If I write this, so I write 27 out of 104. And I'm going to always label it. So there's 104 total on the team, and there's 27 seniors. The problem with this question is they're asking what percent aren't seniors. I should know right away when I see the word percent, I know my bottom number's got to be 100, because on percent our bottom number is 100 because percent's a ratio that compares to 100. But I want to find out how many are not seniors. So the number that is not seniors. So over here, do you see how my two labels don't match? Well, I can fix that. I can change this to not seniors and doing a little math. If there's 104 kids, if I take away the 27 seniors, does it make sense that the rest would be not seniors? If you subtract the 27 or the 104 minus 27, you're going to get 77. So the numbers actually change. Does that make sense? Okay, I need to find out percent not seniors, which means I'm just going to multiply across. So 77 times 100, that equals 7,700, and then you're going to divide by 104. Oh, that's going to be a decimal. So it's 74.038. If we went, well, a part of a person doesn't really make sense, so we could round that to 74 people. So 74 out of 100, which would say the team has 74%. All right, last two questions here. It just says for the 7th grade standardized test, we received a score of 75%. If there are 80 questions, how many more questions does she answer correctly to receive a grade of at least 95%? Okay, so they have two charts here, which means we're obviously going to do two things. So if we look, this person received 75%. So that immediately goes in my ratio value. That's your ratio they give you. So 75 out of 100. And I'm going to label it. Her score was 75%, which means she got 75% correct. So the number over here is going to be correct. And then 100% is always going to be total. Guys, now that we're moving into percent problems, I'm going to be really insistent that you label the tops, but the bottoms I'm not going to really demand that are labeled because the label's always the same. It's always 100. It's always total. So it says there are 80 total questions. So that would be, go right there. I'm going to multiply across and divide to find out how much she got correct. So I'm going to go 75 times 80, and then I'm going to divide by 100, which is 60. So she already has 60 right. We want her to get 95%. So I'm going to immediately put that 95 means 95 out of 100. That's my ratio value. And I'm going to label it again. We want her to get 95% correct. So I'm going to put a correct over here. And again, the bottom is total. The test is going to be the same. It's still going to have 80 questions. I'm going to multiply across and divide to figure out how much right she does need to get. So you're going to take 80 times 95, and you're going to divide by 100, and you're going to get 76. So for her to get 95%, she needs to have 76 right. Right now, she has 60 right. The question is, How many more questions does she need to answer correctly? Well, you can see if you compare the 60 to 76, she needs 16 more questions correctly.